Hey everyone, it's Miss Bertuman here to welcome you back. Today we're going to be solving two-step multiplicative word problems. Let's begin. Read the word problem with me. The table shows the cost of party favors. Each party guest receives a bag with one balloon, one lollipop, and one bracelet. What is the total cost for 9 guests? What information do we know so far? We know that each guest receives one of each item. One balloon, one lollipop, and one bracelet. How could I draw this? I was thinking that we could draw a tape to illustrate this. One balloon is 26 cents, one lollipop is 14 cents, and one bracelet is 33 cents. We also know that there are 9 guests at the party. How can I show this in this model? Well, here I have 1 unit. This can represent what one guest receives. I can draw 8 more units, and this would be a total of 9 guests. Let's go ahead and do this now. How can we determine the value of 1 unit? We could add 26 cents plus 14 cents plus 33 cents. Do this with me now. What is the cost for 1 bag for just 1 guest? It would cost 73 cents. Is this what the word problem is asking us to solve? No, we need to find the total cost for all 9 guests. So we're going to go ahead and mark this 1 unit as 73 cents. But again, we're trying to figure out the cost for all 9 guests. So we'll mark this unknown in our model with the variable P. How can we solve for the variable P? We need to multiply 73 cents times 9. Do this now. What is the cost for all 9 guests? The total cost for 9 party bags is 657 cents, or $6.57. Let's write a statement in now. I'm wondering, is there another way we could have solved this problem? You know what I'm going to do? I'm going to go ahead and call Mrs. Gradney to see how she solved it. 1 second. Hello? Hey, Miss Gradney. Thanks for picking up. I'm here with the students.
Oh, hi, friends.
You know, we were wondering, did you already solve the first math problem for today? The students and I already solved it together, but we were wondering if there might be a different way to solve it.
Sure thing. I can share with you how I solved it. I'll send it to you now. Okay, I sent it.
Thanks so much. See you later, Mrs. Gradney.
See you later.
Let's see what Mrs. Gradney sent. I'd like you to go ahead and pause the video here. Take a moment to compare Mrs. Gradney's work with ours. How is it similar to ours? And how is it different? We'll share our findings when we get back together. Welcome back. What did you notice? I noticed that Mrs. Gradney and I arrived at the same answer. However, we approached it quite differently. First, I added the cost of each item together. Then I multiplied that by the number of guests. Mrs. Gradney first multiplied the cost of each item times 9, and then she added all 3 products. You know, it's always nice to be able to phone a friend for help with a word problem, whether it be because you're unsure about drawing, or even if you just want to compare your work. I also know that by comparing my answer with Mrs. Gradney's, I can see that my answer is reasonable because we talked through our thinking and compared our answers. I highly encourage you to do the same. The Turner family uses 548 liters of water per day. The Hill family uses 3 times as much water per day. How much water does the Hill family use per week? Let's go ahead and reread the first 2 sentences together. The Turner family uses 548 liters of water per day. The Hill family uses 3 times as much water per day. Can we draw something? Yes. What is it that we can draw? I'd like you to go ahead and pause and draw something that represents what we know so far from just the first 2 sentences. We'll compare our drawings afterwards. Here you can see that I've drawn 2 tapes. The first tape represents how much water the Turner family uses per day, which is 548 liters. The second tape represents how much water the Hill family uses. We don't know the actual amount, but we do know it's 3 times as much as the Hill family, which is why their tape is 3 times as long. Before we begin to solve the problem, I want to go ahead and make an estimate of the value of this tape. Now, I know that the number I'm looking for is going to be bigger than 548 because it's 3 times as much. So let's quickly estimate. If I round 548 to the nearest 100, that would be 500. And then I can use 500 times 3 to estimate that my answer would be around 1,500. So when I'm done solving, I'm going to make sure that my answer is close enough to be reasonable. So let's figure out how much water the Hill family actually uses per day. We can do this by multiplying 548 liters times 3. Do this with me now. How much water does the Hill family use per day? The Hill family uses 1,644 liters of water per day. Let's go ahead and label that now on the tape. Let's read the final sentence in the word problem again. How much water does the Hill family use per week? We already know how much water the Hill family uses per day. How can we determine how much they use per week? We can multiply how much they use per day, 1,644 liters, times 7, since there are 7 days in a week. Pause the video here to do this now. Oh, and before I forget, be sure to include a statement. I'll see you here in just a moment. How much water does the Hill family use per week? The Hill family uses 11,508 liters of water per week. Read the problem with me. Jaden has 347 marbles. Elvis has 4 times as many as Jaden. Presley has 799 fewer than Elvis. How many marbles does Presley have? I'd like you to go ahead and pause the video here to draw a model that represents this word problem. We'll compare our models afterwards. Here you can see the first tape represents Jaden's marbles. The second tape represents Elvis's marbles. And we can see that it's 4 times as long as the first tape. The third tape represents Presley's marbles. Why is Presley's tape shorter than Elvis's tape? It's because Presley has 799 less marbles than Elvis. What is it that we're trying to find out? We need to find out how many marbles Presley has. So I've labeled it with the variable M. Next, I'd like you to pause the video here to solve for M. We're going to go ahead and compare our work afterwards. Of course, don't forget to include a statement. See you back here in a bit. Hey, welcome back. Go ahead and take a moment to compare your work with mine. Here you can see that before I actually solved, I went ahead and estimated what I thought my answer could be. So I first solved by estimating around how many marbles that Jaden had, which is 347. That's about 350. So I then multiplied by 4, since that's how much Elvis has, and that is 1,400. Now Presley has 800 less than that. It's actually 799, but again, I estimated. And so I subtracted 1,400 minus 800, and that equals 600. So I know my answer is going to be around 600 marbles. From there, I went ahead and tried to figure out the actual answer. I first solved for how many marbles Elvis has. I multiplied by 4, 347 times 4, and that equals 1,388. And since Presley has 799 less marbles than Elvis, I subtracted. But instead, I decided to make an easier problem. I subtracted 1,388 minus 800. That equals 588. Then I added one more back in, since Presley has 799 less than, not 800 less than. And that equals 589. Look, I know my answer is reasonable because it's so close to the estimation that I made earlier. So how many marbles does Presley have? Presley has 589 marbles. Today, we solved 2-step multiplicative word problems. Excellent work. Be sure to check in with your teacher, especially regarding problem 4 of your problem set. We'll see you around soon for another Eureka Math lesson. Bye, and enjoy the rest of your day.